Okay, so as you saw in the previous lesson, when we were changing the location value of the vertex, it can only move on the XYZ coordinate system. It didn't matter if we were changing the location or the rotation. So the same thing is going to be true when we are changing its scale. All this vertex can do is change its location on the XYZ coordinate system. So this again is going to be true on the object itself, which you're going to see a little later. What I want you to do first is switch to edit mode and click on this vertex and go ahead and zoom in a bit. Do shift middle mouse button to pan. Now do shift D to duplicate this vertex to create a very simple circular pattern. It doesn't have to be perfect. Now go ahead and click on this vertex. So what's actually happening inside the 3D view with this 3D manipulator is that when you click on a vertex, an imaginary line is being drawn to where this 3D manipulator is that gives us the ability to move this vertex or rotate this vertex and scale this vertex. So right now when we press the G key, we're simply changing its XYZ location values. Now when we press the R key, as I've shown you, it's not actually possible to rotate a point. But Blender, because it's using the 3D manipulator to handle this vertex, allows you to actually rotate this vertex based on where the 3D manipulator is. So here what I want you to do is click your left mouse button anywhere over here to bring the 3D cursor, and we can force the 3D manipulator to move away from that vertex by going 3D cursor. Notice where it ends up. So here what the vertex is doing is really drawing an imaginary line to the 3D manipulator, because you've seen in order for this vertex to rotate or change its location or scale, it needs another point of reference, so it uses the 3D manipulator. So right now when we press the G key, what's actually happening is that we're not seeing the 3D manipulator, but that offset is being maintained by this vertex. Right click to cancel. Now when we press the R key to rotate, you can see that the vertex is behaving the same way that we saw in the previous lesson. It's basically rotating around the 3D manipulator by simply drawing a line to it, right? A vector. Now we're going to press the S key to scale. So you can see here the distance is being increased between the vertex and the 3D manipulator, basically with this imaginary line. Right click to cancel. Now what I want you to do is go ahead and left click to bring the 3D cursor over here and switch this back to median point. Now when we press the C key and go ahead and select all these vertices, notice where the 3D manipulator is going. So each individual vertex is going to do the same thing. They're all going to draw an imaginary line to where this 3D manipulator is and use that offset to maintain the distance when we are moving them, rotating them, or scaling them. So if we press the G key, you'll notice that all the vertices, when they are moving, we get to maintain our pattern, right? Because the offset is always going to be maintained. Now when we press the R key 2 times, all these vertices are really just rotating around the 3D manipulator, right? By drawing this imaginary line to it. Now when we press the S key to scale, you can see that the same thing is happening. So what we're going to do is do Shift S and do cursor to selected. Now do Alt E and extrude vertices only. Right click to cancel, do Shift S and do selection to cursor. Now we're exposing what these imaginary lines look like, right? So now just do the A key to select everything. Now when you press the G key to move, you can see that how these vertices are always maintaining that distance with the 3D manipulator with these vectors, these lines. Now when we press the R key 2 times to rotate, you'll see that the same thing is happening. Each individual vertex is simply rotating at the same time around this 3D manipulator. This allows us to maintain this pattern that we've created. Now when we press the S key, you'll see that the same thing is happening. The distance between the vertex and the 3D manipulator is being increased by simply increasing the length of these imaginary lines. Now do X and delete all these vertices. We're going to go ahead and zoom out quite a bit and click the left mouse button over here and do Shift A, and we're going to add a torus. Do Shift middle mouse button to just bring it into view. Now since all the vertices are selected, we're going to do X and delete only edges and faces. Press the A key. You will see that the vertices have no idea what this shape looks like. They only know their positions inside this 3D view, right? Their locations on the XYZ coordinate system. So when we have all the vertices selected, the idea is exactly the same. So when we press the G key, right, all these individual vertices are drawing a line to where the 3D manipulator is and maintaining that offset, giving us the ability to move this object. Now when we press the R key 2 times, it's doing the same thing. Okay? And when we press the S key, it's doing the same thing. So we're going to expose this. Press the 7 key. Now do Alt E and do extrude vertices only, and right click to cancel. Do Shift S and do selection to cursor. Now press the A key to select everything. Now this is going to look a little complicated, but here you can see that this is how this is being done. When we press the G key, the distance by these imaginary lines that each individual vertex is drawing to the 3D manipulator is kept intact. This is what allows us to move this torus, right? And now when we press the R key, you can see that how each individual vertex is rotating around the 3D manipulator. Same thing with the S key, right? If we scale, we're really just increasing the length of these lines between the vertex and the 3D manipulator. So this is how it's working internally on a coordinate system. Now, what I want you to do is go ahead and open up Rigging Lesson 02 L.blend. This is the last file we had left off. Do not save anything in this file. What I want you to do is go ahead and click on this figure, go to the modifiers tab, and here we're going to apply the mirror modifier, and on the subdivision make sure that it's set on 1. Go ahead and apply it. Now when we click on this figure and switch to edit mode, we're going to press the A key to select everything. We're going to do X and delete only edges and faces. Now press the A key to select everything. So here you can see that really it's the position of each individual vertex that defines this realistic version of the human figure. Now notice that because all vertices are selected, where the 3D manipulator is. So each individual vertex is now going to draw a line to where this 3D manipulator is. So when we press the R key 2 times, you can see that it gives us the ability to maintain our original 3D model's shape. Okay? Now the same thing is going to be true that if we do Shift C to place the 3D cursor over here and now force the 3D manipulator to go to the 3D cursor, when we press the R key 2 times, we can rotate around any point, right? Because that's how the vertices are doing. They will draw a line to wherever the 3D manipulator is to always keep that offset maintained. Now go ahead and switch this to median point. What I want you to do is first go ahead and go to the armature, click on this bone, make sure that it's in pose mode, do Shift S, and you're going to do cursor to select it. Notice that the 3D cursor is going to go to the head of this bone. Now go ahead and click on this figure and switch to edit mode, and go ahead and just click on any vertex over here. So what we're going to do is open up this data panel, make sure that there's nothing over here, and here we're going to click on the name of this bone, which is dev.arm.upper. Click it. Now do A to D, select everything over here, and you're going to select. Notice that how these vertices are getting selected because they are assigned to this vertex group that the bone is using to pose your figure. So what I want you to do is press Alt E to extrude on vertices only. Right click to cancel. Now you're going to go over here and you can do remove from all groups. Now it's very important that over here we're going to assign a value of 1, meaning that this is the only vertex group that will be assigned to these new extruded vertices. Go ahead and click it. Now we're going to do a Shift S, and we're going to do selection to cursor. The reason I'm doing this is I want to show you that how this concept is now going to work when we're working with an armature. So over here, when we click on this bone, this is in pose mode, you can see that when we press the R key, all these vertices that are using that vertex group with this bone are simply drawing an imaginary line to the head of this bone, right? This is what they're doing. They're rotating around the head of this bone. So now when we, let's say, click on this bone and press the R key to rotate, right? You can see that point is always travels wherever the head of this bone is going, right? So this is what gives us the ability to do this. Now go ahead and press A to select everything, do Alt R to reset the rotation. Now go ahead and click on the figure and press the tab key. Now what we're going to do is actually click on this vertex and go ahead and select the dab dot shoulder vertex group and do A to D select and just do select everything over here. Notice that some of the vertices that were coming from this upper arm bone are also getting selected. So here we're going to do Alt E and do extrude vertices only. Okay, right click to cancel. We're going to do the same thing. Go over here and remove from all groups on these new extruded vertices. Now we're going to make sure that we're going to only assign them to the dab dot shoulder. Now we're going to have to switch to the armature and go ahead and click on this bone, do Shift S and do cursor to select it. Then go back to the figure, press the tab key. Now do Shift S, and here we can just do selection to a cursor. So you'll see that this is where they're going. Now go ahead and click on the armature and click on this bone. So you can see that when we press the R key over here, all these vertices that are looking at this bone are going to rotate around the shoulder bone, right? And if you click over here, press the R key, these vertices are going to rotate around the dev dot arm dot upper dot L, and because some of these vertices are also looking at this bone over here, they're going to draw an imaginary line to the head of this bone too. So they're going to fight between the influence, but here it'll give you a better understanding as to how the deform concept works, right? It's really, again, working with this idea of rotations on the head of this bone. Now go ahead and click this and press the tab key, and now press the A key to select everything. And what I want you to do is do Alt E and do extrude vertices only. Now this is going to get quite complicated. Right click to cancel. Now over here we're just going to remove from all groups. Now what I want you to do is do Shift C to place the 3D cursor in the center, and here we're going to force the 3D manipulator to go where the 3D cursor is. Now we're going to do Shift S and do selection to cursor. Now you'll see that how complex the math actually is to allow us to rotate this figure just in edit mode, right? So if we press the A key, you can see that how each individual vertex is going to have to draw a line to where the 3D manipulator is. So when we press the R key 2 times, this is what allows us to rotate our figure inside the 3D view. So I just want you to have a visual understanding of what actually is going on with rotations first, right? So now go ahead and switch back to the Bone Concepts 8.blend. So now that you've seen how this idea works, the question is going to come down to how are rotations determined on a coordinate system. It's actually very easy. So here, what I want you to do is, having this object selected, do Shift S and do cursor to selected. It'll bring the 3D cursor over here. Now we need to go to the grease pencil, click on a line, and just draw a line on the y-axis, and now draw a line on the x-axis. This is because, now do the escape key. This is because when we switch to edit mode, the axis will disappear, but we can actually see what the coordinate system looks like. So now click on this vertex and press the G key to move this vertex inside this internal local coordinate system, right? So the way rotations are created is of course going to be based on a coordinate system. So basically we can put this vertex anywhere that we like. So what we have to do in order to understand what angle this vertex has rotated around the center of this coordinate system, what we can do is press the E key to extrude this out. Because the 3D cursor is over here, I just want you to do Shift S and do selection to cursor. So you can see that this vertex over here is going to draw a line to the center of its local coordinate system. So we can press the G key and move it. So here you can see that we're getting an angle over here. If I go to draw, you can see that what we get is an angle over here. Okay, so how do we figure this out? All we have to do is actually do E to extrude this vertex, right click to cancel, and just drop a line right down to where the x-axis is, right? So here we're going to be dealing with the Pythagorean theorem, meaning that the height of this vertex that is being shown on the y value is the opposite, and this line over here is the adjacent, right? So meaning on your calculator, this is your sine value and this is your cosine value. So here, if we bring up a calculator by looking at this vertex, we can simply see that this is .505. So here I'm going to go to a scientific calculator, type in .505, and here we're going to divide this by the adjacent value, which is the x, which is .734, right? So divide this by .734 will give us this number. And here we're just going to click over here to get the inverse tangent. Click it. Here is showing that it's 34 degrees, meaning that this angle over here. Okay? So now how can we prove this? We can simply go back to the grease pencil, and over here you'll see under tools, it's a ruler and protractor. Click it. Now you're going to press the control key down and click once with your left mouse button and drag it and let it go. Now you can just click with your left mouse button and move this point over here, select this line, move this over here, select this line and move it over here. So you'll see that it's showing you the same thing, 34 degrees, right? So this is how we can get angles out of a coordinate system. Right? This is the only way to do it. There's really no other way to understand how angles are. So now to get out of the ruler, you actually have to press the escape key to get out of it. Okay? So now you understand this idea over here. So now the question is going to come on the object mode itself, right? When we click on this object, actually remove the grease pencil and press the R key to rotate, you can see that the numbers are changing over here, right? But you saw that when we were getting the angle of the vertex, we actually have to move the vertex on a coordinate system. But when we are rotating this object is not even moving, right? So where did it get this rotation from? So this is what we're going to understand in the next lesson. So go ahead and just reload this file, and I'll see you in the next lesson. Thank you.